the third event of this year's Energy Symposium series, Critical Issues in Energy. Tonight's topic, as you all know, is offshore wind. Will it happen in Texas? I'm Ramanan Krishnamurthy, the Chief Energy Officer here at the University of Houston. Welcome to the symposium. We have an outstanding panel here and moderator, and I'd like to thank everyone for their participation tonight. I'd like to especially thank Equinor for being the presenting sponsor for this event, and our media partners, Houston Public Media, who help spread the word and also help us with the reporting of this event. I'd like to recognize members of our President's Energy Advisory Board. The Energy Advisory Board is made up of industry experts and leaders who give UH and UH Energy strategic guidance to advance energy education, research, and outreach. I'd like to thank some of my faculty colleagues here who are energy fellows who contribute not only to the symposium but also thought leadership across all of our different energy-related issues that come up from time to time. I'd like to thank our student volunteers from the Energy Coalition. The Energy Coalition, for those of you who don't know, is the largest student organization anywhere in the country that is focused on energy-related matters. So an outstanding organization, and we thank them for their support. A few quick notes about the event today. If you can't make it live, and I think some of you might be thinking of going off somewhere through this program, you can continue to follow us through our Facebook Live program. If you can wait till Tuesday, we will have it on our YouTube channel, and that YouTube channel has all 23 of the previous symposia on that channel. So in terms of Q&A, I'd like to encourage you to submit your questions. You can do that through an online link that will appear. I strongly encourage you to use your phones, media, anything that you want to go in there and put your questions in. So the link will show up periodically, so you don't have to follow it along as we go through this. I'd like to introduce our moderator, Cheryl Stahl. Cheryl is a senior principal in offshore wind advisory at DNV-GL. She is a Houstonian, as she very proudly told us a few minutes back, and we're delighted to have her here. She has more than 30 years of experience in environmental and safety consulting, currently focusing on offshore wind development in the Americas. Her career began in environmental impact evaluation at the US DOE facilities. For more than 15 years, she led risk assessment in the oil and gas industry. She led the DNV-GL safety risk practice in North America for 5 years. Following that, she initiated and has led the DNV-GL navigation risk practice in the Americas. She has significant experience in international due diligence, complex environmental and safety regulatory issues, and risk acceptance criteria. For the past 3 years, Cheryl has been involved in permitting for offshore wind projects in the US, including site comparisons, marine navigation risk, decommissioning cost estimates, and identifying the US supply chain. With that, I present to you Ms. Cheryl Stahl, who will be the moderator for the event today. Thank you.
Thank you, and thank you all for coming tonight. This should be a really lively group, and I'm looking forward to hearing what the fantastic panelists have to say. Before we go too far, I just want to set the stage and open up the topic a little bit before they go deeper than I can. Concerning offshore wind in Texas, there's a lot of deep expertise from oil and gas here. There's a lot of wind resource. Texas has been a leader in land-based wind. But the question is, are we going to go into offshore wind here in Texas, and what would that take? Okay. Well, offshore wind is not a new area. It's been, excuse me, In Europe, offshore wind has been under development for many decades, and Germany and UK lead the way. Is it possible to get the monitor down here working? I have no idea which slide you're looking at.
It's a video of you.
Fantastic. Does that change anything? No. Okay then. That's fantastic. Okay. But what we have is a situation where UK is growing at a fantastic, offshore wind at a fantastic pace. And in Scotland, they installed their first floating offshore wind demonstration that's commercially producing electricity, which is very exciting. Most of what's going on here in the U.S. is in the Northeast. You probably already know that, and our distinguished guest will be talking a lot more about that. There's a lot of activity in lease areas, and it's all fairly new. So back in 2015, there was a lease off Massachusetts, and there was no interest. In 2018, there was record-breaking interest. So what we're looking at is an explosion in the U.S., and we may be able to catch up to the world's production in offshore wind in a very few number of years. It's really an exciting time. There's interest both on all the coasts. Certainly Northeast is leading the way, but the Pacific Coast, California, Washington, and Oregon have been talking about it. There's another step in approval for the Great Lakes, Lake Erie, and now we're here talking about Gulf of Mexico, which I wouldn't have dreamed of even 5 years ago. So with that, let's get to our panel of experts here. We'll start off with Jim Bennett. He's the program manager for the Bureau of Ocean Energy Management's Renewable Energy Program, where he oversees development of renewable energy resources on the Outer Continental Shelf. The program now manages 15 active leases covering nearly 1.7 million acres on the OCS, ranging from Massachusetts to North Carolina. He previously led the Bureau's Division of Environmental Assessment, overseeing compliance with the National Environmental Policy Act and other environmental laws. He has been involved in projects including the Exxon Valdez and the Deepwater Horizon oil spills, the Cape Wind Energy Project, and offshore renewable energy activities off the Atlantic coast. He has a master's degree in environmental planning and computer systems management. Jim will cover the overall activity in the offshore wind sector, what has happened, what's currently happening and why, and what will likely happen in the next decade. I can't wait to hear that. He will be focusing on the Atlantic and Gulf of Mexico activities. Next, we'll have Deniz Ekici. Deniz is a marine operations manager for Equinor and has more than 15 years of experience in engineering and managing large capital projects, including offshore wind development in Northern Europe and Asia. He has published a number of technical papers on oil and gas, as well as offshore wind, and presented at conferences including the Offshore Technology Conference Houston, the Offshore Technology Conference Asia, and the American Wind Energy Association's Offshore Wind Power Conference. He is a licensed professional engineer and holds certification from the Project Management Institute. And Deniz will be discussing the industry supply chain and development in the U.S., which is certainly going to be something growing exponentially in the coming years. Next, John Hartnett is a business opportunity manager for Shell Wind Energy and president of Mayflower Wind Energy. That's a joint venture between Shell and EDP Renewables established to develop projects in the New England region. Mayflower last year acquired a lease off the coast of Massachusetts. And maybe there's news today on progressing that forward. A second joint venture with EDF Renewables, Atlantic Shores, holds a lease off the coast of New Jersey and will develop projects for the New York and New Jersey markets, among other states. The two ventures together hold more than 300,000 acres of offshore leases, with the potential to develop more than 4,000 megawatts. Hartnett has been with Shell for 17 years and in the energy industry for more than 30 years. John will discuss Shell's development plan, and additionally, he will touch on market structure, risks associated with development, and lessons learned from offshore oil and gas production, and he will also focus on the Northeast region. And then capping it off will be Michael Osborne. Michael is a co-founder of the Texas Renewable Energies Industry Alliance and has worked on renewable energy and climate change issues since the 1970s. He was involved with Texas's first wind farm installed in 1981. An activist and speaker, he's a member of the City of Austin's Electric Utility Commission and the city's Joint Sustainability Committee. He served as a chairman of Austin's Generation Resource Planning Task Force, which aims for 65% of the city's electricity to be generated from renewable resources. Osborne previously served on the steering committees of the Texas Energy Policy Partnership, the Sustainability Development Council, and the Texas Energy Coordination Council. His most recent book is Beyond Light and Dark. He will give the economics of wind on land versus offshore, where the industry is now, and what the possibilities are for the future. And with that, I will hand it over to Mr. Bennett.
Thank you. I was hoping to run a little longer so that the video could come up. I have a whole bunch of things that I'd like to show you, but I'm going to have to just tell you about them under the circumstances. So thank you again for this opportunity to speak with all of you. My name is, again, Jim Bennett. I'm the program manager for Offshore Renewables for the Bureau of Ocean Energy Management, which is a federal agency in the Department of the Interior, and we manage over 2.3 billion acres of offshore area everywhere. Well, this is Texas, but typically 3 miles offshore and out to the end of the exclusive economic zone. Here in Texas, it's about 9 nautical miles offshore and then out into the Gulf of Mexico. You are undoubtedly already familiar with our oil and gas program, which has been operating in the Gulf of Mexico for many decades now, producing about a quarter to 30% or so of domestic oil and gas production. I'm here to provide you a little bit of the federal perspective. I'm sorry? Oh, you can? Okay. Too bad I can't. Okay. Let me, I can see that one pretty well. Let me just mention before we get on onto activities on the East Coast. I'm going to focus on the East Coast activities to give you an idea of the activities that are going on. But there's 3 basic components to a successful wind farm operation offshore, and that's the first and foremost the wind resource itself. Secondly, a buildable environment, and thirdly, market demand. And we enjoy those in various degrees in the 4 regions that constitute the Outer Continental Shelf lands. I want to mention where we are on the East Coast. These things come together in a very big way on the East Coast. We have world-class wind resource, we have world-class markets, and we have a shallow sloping shelf which allows for the current technology of bottom-founded wind turbines to be built in a cost-effective manner. We have 15 commercial wind energy leases in the Atlantic, with the 3 that was mentioned a moment ago that we recently issued in Massachusetts at an absolutely incredible commercial interest in those areas. Almost 1.7 million acres. Every state from Massachusetts to North Carolina now has at least 1 federal lease for offshore wind. And there are diverse leaseholders. We have 9 companies that include a lot of international interests as well as domestic companies. So we're in the midst of dealing with a lot of plans, site assessment plans. The first wind farm went in Rhode Island, Block Island, that you may be familiar with. That's a state project. We had some involvement with the cabling, but it is a state project. So we're looking forward to the first federal steel in the water very soon. Could you go back? Well, maybe I could go back. Maybe I can't. Yeah, okay. So we have 7 site assessment plans that we have approved for leases on the East Coast, and we're currently working on processing 3 construction and operations plans. And an additional 8 or maybe even 9 are expected within the next year. So things are happening up on the East Coast. We're looking to get steel in federal waters by 2020. Either the Vineyard Wind project up in Massachusetts or the CVAL project, which is a demonstration project off of Virginia. In addition to the leases offshore, in order for it to move forward, we need to have onshore support. And this includes port facilities. This includes testing centers like the blade testing center in Massachusetts, as well as the turbine testing center down in South Carolina, and academic institutions that will train the workforces for the future. I want to also mention Gulf Island fabrication, if you're not already familiar with it, because I think this is one of the major aspects of activities in the Gulf of Mexico that can support an offshore wind energy industry. And of course, a key component of moving forward is the ability to ensure power purchases, which the states have started to develop in a very, very big way. And it's the states such as Massachusetts and New York identifying 3.2 gigawatt, and in the case of New York, they just upped the ante to 9 gigawatt for offshore wind, and that's huge. That's what's contributing to the demand. We have a lengthy process. The regulations that move the program, that guide the program, were issued in 2009. We're just now getting to the point where we're going to have steel in the water, so you're talking about 8 years, 10 years, a little longer up front, of course. But the good news is that we're coming to the end of that first 8 or 9 year process, and we have projects coming on in a big way over the course of the next decade. As you can see, as this screen populates with the specific projects that have been identified for the existing leases, we've got 10 or 12 projects that are going to be going in over the course of the next decade. What does all this mean? Well, in terms of issues and opportunities, there's a tremendous potential for jobs, 10,000 FTE equivalents, FTEs with regard to construction of an 800 megawatt farm, which is typically the size of a farm that we're pursuing in the Northeast. 10 to 15,000 employees on an ongoing basis as the industry matures. And the local content, which has to be pulled from elsewhere, such as the Gulf of Mexico and from Europe, expanding from 40% to upwards of 70%. I mentioned that about the Gulf of Mexico because the first wind farm up in Rhode Island was built literally on the foundations of the oil and gas industry here in the Gulf of Mexico. The foundations were built at Gulf Island Fabrication and barged up to Rhode Island, and the turbines installed on those foundations. It's because we have that kind of an industry here in the U.S. that these synergies can develop so that we can work in the offshore environment without having to invent the wheel, so to speak. Technology is a huge issue, not only for the East, where we're going directly to full-scale wind farms of 800 megawatts or thereabouts, but this gives you an idea of the size of turbines that have developed over time. And the first one in 1991 was a little bit smaller than the Statue of Liberty. What's being deployed now, the Block Island Farm wind farm is at 6 megawatts, and there's 5 of those. What's being deployed now is about 8 megawatt machines. GE has announced a 12 megawatt machine. Vineyard Wind up in Massachusetts is planning to use a 9.5 megawatt machine. The point here is that the technology advances the industry. You have a situation with regard to turbines where a doubling of the diameter of the rotors results in a quadrupling of the energy output. So technology is a big factor. And of course, the question always comes up, well, how big is too big? And every time it's answered, they then break that record and move on. And they're currently on the boards looking at a 50 megawatt machine that they want to build a prototype by 2025. It's pretty incredible what technology can do, and I think that that's one of the things that would make the industry work in the Gulf of Mexico. So, I hope I'm doing okay on time. I want to leave you with one comparison of the United States, the East Coast of the United States, and what's going on over in Europe. In this case, the wind farms off of Great Britain. This is the land area with gives you an idea of the demand, the electricity demand that these areas generate. The two areas that are pretty comparable in terms of the length of coast, somewhat comparable in terms of population. The number of active projects, they're actually projects over in Great Britain, but we have 15 leases, like I said, and about a dozen projects associated with those leases that will be moving forward. They started a while back, 2004. They've got about 5 gigawatt in place at this point. But the really important thing, the really interesting thing to my mind is what's on the boards. We're looking at about 10 gigawatts on the East Coast. And while we are building our first 10 gigawatts on the East Coast, they already have plans for 28 gigawatt over in Britain. And this is also mirrored on the continental shore of Europe, Germany, Belgium, France, etc. They have similar numbers. So there's great prospects for offshore wind energy, and I'm looking forward to the discussion. And if you put my information up there, if you want to contact us and if you have any questions other than what we're going to answer today, please feel free. And thank you very much.
Let's see. Perfect. Okay. Good evening, everyone. Thank you for coming in tonight. My name is Deniz Ekici. I'm responsible for Equinor U.S. wind marine operations in our east and west coast operations. Some of you may know us better with our old name, Statoil. We come from a strong offshore oil and gas background. Times are changing, so are we. We are making a transition, and we are becoming a global energy company. Given our background, strong background in offshore oil and gas, offshore wind is a natural transition for us, and here we are. These are a little bit background about our U.S. East Coast operations. We recently, a couple of years ago, obtained a lease in the New York area, and another one recently in Massachusetts. The business driver is New York and New Jersey. These are the first big ones that came in. Overall goal about 9 gigawatt in New York, and then 3.5 gigawatt in New Jersey. And we see that it's an ongoing trend, and it will carry on. And we also see in other New England states that are increasing interest. For example, Massachusetts, there's more procurement opportunities coming up. Connecticut is, of course, is not behind in the race. They announced their 2030 targets, 2030, 50. And in wider New England area, we see that Maine eventually coming on board as well as New Hampshire. In Rhode Island, it's a smaller state. We're expecting small increments in their respect. So what do we do in the US? We practically look into East Coast and West Coast operations. for East Coast, of course, because of the shelf conditions, the key growth region for bottom-fixed offshore wind applications. We are looking into building a long-term portfolio in the region. We are positioned for future opportunities on the East Coast. As well as West Coast, it's a different condition from a water point of view, and because of the non-existence of the shelf and then the quickly deepening the water depth, we are looking at the floating offshore wind applications in the West Coast. And we are well positioned given our proprietary technology with high wind, floating wind technology, which is first we developed in Scotland and then deployed in a commercial grade as well, and we are gaining a lot of valuable information in this respect. Okay, so the supply chain. So we want to build these offshore wind farms. What do we need? We need ports, we need grid connection, we need vessels with automatically ties to a 1920s rule called Jones Act, which means you cannot operate a foreign flag vessel within the continental United States with carrying commercial cargo between two US points, which means eventually we have to build our own vessels. And the local content. Local content is a state issue in most extent. Some states require attention to it, and some states bypass it. Now the ports, we have our infrastructure is being developed, but the general tendency we see over here in the United States right now, where Europe was 20 years ago, before they have all the infrastructure developed, but it's a tendency over the time, the supply chain will be developed. And we see that us as developers have a key role in developing the supply chain, guiding the interested parties in the right direction in terms of what we need to develop these wind farms. So opportunities in Texas. What can we do in Texas for offshore wind? First of all, there's the transferable oil and gas experience. It's a very strong state, years of experience, which is can be directly related to offshore wind applications. Competent workforce, this is very important. A lot of engineers, a lot of companies, they know what they are doing and they've been doing it for a while. Capable fabrication and port facilities, like Jim highlighted, this is in the Gulf. You can find world-class fabrication facilities. They got the manpower, they know what they're doing, and then they will be providing the right equipment at the right time when you need it. Home to many offshore oil and gas service companies with transferable knowledge to offshore wind projects. So from engineering, the marine operations, the logistics, so they know how to run complex projects. That's a great advantage. There is no other state in the country that has that much background information. And the most important, experience with large, complex offshore projects. Now, if you look at typical offshore wind projects, and you build 1, 2, 3 over time, what you notice is that it's a logistics campaign that you're running. The technology is there, yes, next generation turbines come in, new platforms come in, like Jim highlighted, GE recently came up with a 12 megawatt turbine. That comes with a new platform. Think it like a car chassis. So because of that new platform, it opens the road to wider, bigger turbine applications. So in near future, we will see 13, 15, up to 20 maybe, megawatt turbines based on the same platform. Siemens recently announced their Mark V turbine, which is again is a new platform, again opens the road for new applications in terms of capacity. So they will be there. Another opportunity in Texas is, given the high oil and gas applications offshore, our Hywind-Tampen project is a good opportunity for potential coexistent example between offshore oil and gas and offshore wind projects. In this particular project in North Sea, we will be providing power to offshore oil and gas applications with floating offshore wind turbines. We will cut their CO2 emissions. They will not need that big of a diesel generator, which automatically means that their overall topside weights will go down. What's going to happen in the future? 5 years, 10 years, over the time, when this technology is really established in terms of Hywind-Tampen I'm talking about, next time you build a topside, for an offshore oil and gas application, you will say, okay, we will mate it with an offshore wind turbine application. We will cut the weights. When you cut the weight, you cut the cost. That's the main driver in all projects. And this will be achieved in the near future. And this will conclude my presentation. Thank you very much for listening.
Good afternoon. Thanks for having me. John Hartnett. I'm with Shell Energy, as Cheryl pointed out, and kind of represent our joint venture in Massachusetts called Mayflower Wind Energy, which is a joint venture between Shell and EDPR to really to participate in this kind of exciting emerging market in the U.S. Let's see. So a quick overview. Let's see if I walk away from this a little bit. Does this microphone still work? Yep. Okay. A real quick overview. I had an opportunity this afternoon to sit in one of the classes here at U of H and have a Q&A session with the students, which was pretty exciting. And they had a number of questions about onshore versus offshore and the technology and how the system works. And this really is a pretty simple graphic of the industry, but I think it's helpful for us all to understand what's involved. The wind turbines is I think Jim and Deniz talked about and Cheryl how that industry is growing and growing. They're going from I think. Rotor sizes that were 40, 60 meters across, and now this GE turbine has a rotor that's 220 meters across, just magnificent size. The foundations generally globally in the offshore wind industry, I think it's in the area of 85% of the foundations are monopiles. A number of the developers in the Northeast in the U.S. are looking at monopiles as a base foundation type, potentially supplemented with jacket foundations, depending upon the seabed conditions and the water depths. And we have the electrical array cables within the wind farm. Interconnecting into offshore substations, and then a offshore transmission solution bringing the power. These transmission, depending upon how far offshore you are, the undersea transmission cabling can be 30, 50, 80, 100 mile long solution, and then. The landing, the onshore, in all likelihood, overhead lines to get to a substation where we'd be able to interconnect into the grid. The benefits of offshore relative to other solutions is the wind resource. Jim mentioned the wind resource in the Northeast. The Northeast United States has very, very kind of consistent, strong winds that provide for a real nice resource. I think looking at the Texas and some of the Midwest corridor in the U.S. for land-based wind generation, we see similar, possibly not quite as strong, but similarly strong wind resource. But for the Northeast, that's a huge benefit. The space, Jim, did you say 1.7 million acres of leases, and that just represents a very small percentage of the leasable area up and down the East Coast for the wind development. We're not working with towns and villages, cities, hills and valleys. It's you know, pretty straightforward development landscape. So that's a huge benefit. And you know, I think as Deniz showed, the population centers up and down the East Coast, the demand, the demand and the access to the demand. Again, here in Texas, we have a lot of wide open spaces where we can develop onshore projects. In most of the East Coast states, the Northeast states, the land available for energy development is, you know, we're not as fortunate as Texas, so it provides for a great area. On the downside, these are much more complex projects. They're much more capital intensive projects. You know, although we see we see the prices coming down significantly, these remain pretty capital intensive. The challenges, you know, I think Deniz pointed out some of the challenges. I'll review some of those as well. It's an industry that's just getting started in the U.S. and it makes for significant risk in the development. And the advancements are moving so fast. When I develop a project and submit plans into you know, if it's a state solicitation, put together my development plans and submit a construction and operation plan as part of my permitting process, I have to lock down my design at some point. And you know, I fully expect that next year, the year after that, the technology is going to be better. It's going to be more efficient, and it's going to be cheaper. So it's hard to, you know, kind of lock in today. What's the market? The market for offshore today is really it's shaped by a public-private partnership. Again, comparing to onshore wind to offshore wind, now the onshore wind industry started out as a public-private partnership, and it's really moved, you know, where the onshore developers are able to develop their projects, enter into contracts with commercial industrial entities or just energy marketing entities, and it's you know, economic and commercialized. Now for developers in the offshore space, we really need to develop and strengthen the public-private sector partnerships. And the public sector, what they bring to bear, along with the private sector, it's a combined effort on site identification and initial development of potential sites for the federal government to develop and issue leases. The leasing and permitting side of it, the leasing is through the federal government. The permitting is at the federal level and the state level, with a lot of local stakeholder engagement as well. So that's, you know, critical on the partnership to have strong public sector involvement and support for the project. The offtake, what we're in the near term, over the next 3 to 5 years, I think virtually all of the offshore wind projects that will be developed with offtake agreements that are through either the states or state policy with the utility sector as the offtake contractors. We're starting to see interest from the private sector for contracts for offshore wind, but certainly for the next, you know, kind of the next several years, we anticipate that the vast majority of the offtake will be through the public sector. And the transmission and interconnection, components of it. You know, although that's the responsibility of the developers, we all are working very closely with the power grids and the state energy authorities and the ISOs to identify and develop strong public policy for interconnection into the system. And then in the private sector, you know, Deniz and I'll talk a little bit about the supply chain as well, but you know, really to fund and build out an effective supply chain for the industry, as well as the funding. You know, here, what we see in the global growth in the offshore wind space, you know, really started in the early 2000s. I think in 2017 there was approximately 20 gigawatts of offshore wind in operation, and the expectations are that you know, the industry is going to grow at a faster and faster rate. The U.S. is just stepping into the market. Jim mentioned what the UK has on the table there. We're seeing very, very significant interest in growth in China, Japan, Korea, a number of other areas. So this is an industry with tremendous growth. And on the price side, we can see that in 2012 we had contracts, you know, over $150 a megawatt hour for power. The first utility scale project in the U.S. In the Northeast, Vineyard, entered into a contract with a number of utilities in Massachusetts, and the price of that is in the $65-75 a megawatt hour range. So in the U.S. we already see prices well below $100 a megawatt hour. But you can see in just, you know, 4 or 5 years the steep decline in the cost curve, and that will continue. This, you know, a little ad for Shell. You know, we have about 300,000 acres of leases, one in a partnership with EDP Renewables and one with a partnership with EDF Renewables. You know, we're looking at developing those areas over the next decade, and you know, it should be in the range of 4,000 megawatts of production. I'm not going to. The offshore targets in the Northeast are growing and continue to grow. I expect in 2 weeks there's an offshore wind conference in New York City, and I suspect that one or more states will step up with significant increases in their state targets. The challenges and risks, you know, I think this touches again a little bit on what Deniz touched about. In the U.S., offshore wind, there is no supply chain. We're looking at tapping into the oil and gas sector, that industry as our supply chain. We've got you know, tremendous, you know, decades and decades of experience and knowledge and partnering with the supply chain in the Gulf region and up and down the East Coast, and we have to continue to foster the development of that in order for us to have an effective and economic industry in the U.S. The ports and logistics. We really don't have any ports that are currently scaled and ready for this industry in the U.S. The port activity, the port development activity, is going to kick off in 2, 3, 4, 5 years. We'll have ports, but unfortunately, I think the initial projects will be relying on ports and foreign lands to do a bit of the heavy lifting and then transporting the material here for installation. Installation vessels, the Jones Act. There are no Jones Act compliant installation vessels for this industry today. If we were to build today, we'd be building purely with foreign equipment. The transmission and interconnection, we have a fairly old transmission system that needs to be further developed for these thousands and thousands of megawatts are going to be coming online. The environmental impacts that virtually all projects have. This is a new industry for the Northeast, and there's going to be very significant environmental scrutiny that we're going to have to be aware of, work with, and be sure we're very attentive to in order for these projects to be successful. And then the stakeholder management. There's other industries that utilize the ocean in the Northeast, and we need to understand their businesses and work with them so that we can coexist and have a thriving offshore wind industry along with a thriving commercial fishery industry, shipping, recreational boating, et cetera. So it's an emerging market. We have some risks. I think as an energy industry in the U.S. and as a supply chain development in the U.S., we've overcome these challenges in any number of areas in the past, and I certainly expect that in a few years the slide won't talk about risks relative to these things. It'll just talk about opportunities for local businesses and the businesses here in Texas and up and down the East Coast. So that's what I have, Michael. Thank you, sir.
Yeah. Is this working? Okay. Hi, everybody. I'm Michael Osborne, and I'm really glad to be here. But I'm kind of curious, why are you guys here? How many people are here because they're just students and you had to come, or Ramadan would give you an F? Nobody? I want hands now. How many people are here because they're interested maybe in getting into the wind industry? There's a lot. There's a lot there. How many here are here because you're just curious about this? Well, that's a lot. Well, I want to tell you a story. I put up a video of me installing the first wind farm in Texas. It was about 40 years ago, and just how long it takes sometimes. I got the video up a week ago. And so I noticed that it's getting some hits, but if you're interested, you can go to Lease the Wind, and I guess maybe Lease the Wind, and maybe go to Michael Osborne or something like that, and then Michael Osborne Energy or something like that will probably come up. But what I want to share with you, for those of you who who lifted your hand and said, you might be interested, let me tell you, I've been in the wind business and the renewable energy business for 40 years, and I made some money, and I'm still making a little, but it was fun, and it also felt good, because I knew I was doing what was good for us all. So if you want a career, there's 10,000 people in the state of Texas alone that are in the wind industry right now. We've got about 5,000 in the solar industry. Those numbers are going to grow, and when this stuff comes online, it's going to grow perhaps twice that amount. There already are more jobs in solar and wind than there are in the coal industry by a large factor. So this is a growing industry, and it's one that I've been in for 45 years. Now, we touched the offshore wind capacity price. We don't really have any capacity here in this state right now. It's all in the Northeast, and there's just a little of it there, just about the blockhouse of 30 megawatts. But if you look at that little yellow line, you see that's running flat at about, 1,500, something like that. I'm sorry, about $200 a megawatt hour. Now, for those of you who aren't electric savvy, you know, $200 a megawatt hour is 20 cents a kilowatt hour. So when somebody says 50 megawatts, that's 5 cents a kilowatt hour. So right now, prices are about $60, $65 a megawatt hour, which is really good considering that it used to be 150. And as you see, as the price drops, then capacity and installations are going to go up. Now, I've got this blurb from the AWEA, which is the American Wind Energy Association, and they basically, you know, they see that the future of big wind is coming in the United States, and that there are 12 active commercial leases for offshore wind development in the U.S. If they were all built, we might get 15 gigawatts of offshore wind capacity. 15 gigawatts, that's a whole lot. Well, we have 23 gigawatts of wind power installed in Texas today. But we're the leading state and one of the leading nations. We got the Massachusetts project. We got the original, we got a deepwater wind project. I pulled this from Utility Dive. There's that 1,600 megawatt 2016 Massachusetts project. And like, as they said, all of this is basically coming about because of the states want to get this going, because it's above market. Quick facts about Texas. Most important one here is Texas leads the nation in wind power generation and produces 1/4 of all the U.S. wind-powered electricity in Texas. Our wind turbines here in Texas produce more electricity than both of our state's nuclear power plants. So it's good business and it's serious business. We produce more electricity than any other state, and we consume more than any other state. We're the largest energy producing state because of, you know, we've got the big industrial complex here in the Houston area, and we just use a lot of energy, a lot more than California. Plus we have the need to do something about our climate because we need lots of air conditioning to live here. So just to get a feel, I pulled this off of the EIA site, which is the energy information. It's a federal data. And this is just for December. I'm making noise, aren't I? This is just for December. Natural gas-fired generation, something around 16,000. It's actually, and then renewables, most of that wind's at 62, 63, something like that. These are terawatt hours now. You'll see that if you added nuclear and renewables together, the wind together, it would be more than coal-fired. So that's on a state level. So we've got a lot of wind, and there's a lot more wind going in. We're at about 22 gigawatts right now. We'll go to 23 or 24 or 25 and headed above that. Now in Texas, we have a unique way of dealing with our generation and electricity. We have a very free market, and where if you produce electricity, you can sell it into the grid, into our ERCOT grid. Texas is one of the few nations, or excuse me, one of the few states. We were a nation, one of the few states with its own independent system operator. And so that means that the green area that you see right there, and a little less than that, but that's all controlled by our people at ERCOT, the Electric Reliability Council of Texas. And if you go to this site, if you're really a nerd and want to look at this, you can go to ERCOT Contour Map, and you can put your mouse over each one of those little squares, and you'll get the price of electricity at that moment in that particular time of day. And when I took this snapshot 2 days ago, you can see most of it's sort of bluish and sort of greenish there. So it's between $30 and $40 a megawatt hour. So that's what was happening 2 days ago, $30, $40. The market's in that range. Now, this slide is going to be the rest of what I'm going to talk about because it's got everything on it that you could possibly want to know to answer the homework question, which was, will it happen in Texas? When will this happen? If you look at 2019, you see that we got 1,500 of solar adds, 3,000 of wind, Look at 223, 6,000 of solar, another 3,300 of wind. Solar still going good in 2028. Wind is now petering out there. That's not really petering out. That's happening because they don't have anything in the queue. But I want to show you that down towards the bottom here, you see the coincident peaks. Those are 78, 83, 89, and 94. That's the total amount of energy that we use at any 1 hour or day, a minute in the system. And of course, it's as it goes up. And then our total energy in gigawatt hours is going from 423,000 up to 537,000. And then this number right here, dollars per megawatt hour, that's the average price that's getting paid in the Texas market. And this year, it was $33. 2023, and this is coming, by the way, from ERCOT. It's not perfect, and it may not be right, but it's about as good a source as we're going to get. $38 in 2023, $51 in 2028, and then by 2033, they're suggesting we'll get that the LMP will be $71. That's based on $4 gas, whereas the other estimations are based on $3 gas. So, if you ask me, when will it happen in Texas? It's going to happen when the price of offshore wind can be sold into the Texas market. And it looks to me like it's going to happen about 2028. Thank you very much.
Well, thank you very much. Looks like it's time for questions, and it was fantastic. The final speaker answered the question with a number, 2028. Anybody else want to throw a number out there?
It'll take that long to come down here.
So some of the questions. So there was a lot of talk about Jones Act vessels and the current lack of Jones Act vessels. What do you see as the solutions being looked at for the Northeast right now concerning installation and construction?
I think I can talk a little bit about this one. So I think everybody knows the definition of Jones Act by now. It becomes an economic question whether you need the Jones Act vessel or not. There are two ways of doing it. Either you build the vessel, but when you build the vessel, you also need a suitable port to be able to operate that vessel. And the type of installation you need out of that vessel. Will it have jacks, or will it operate on DP? And the other part is which will be more economic, using that particular vessel shuttling back and forth between the marshalling port and the installation site. It's not installing at that point. It's basically a transport vessel at that point. It's not an installation vessel. Or use a particular vessel at offshore for installation and use another Jones Act compliant vessel, maybe self-propelled or not, to shuttle components back and forth between the marshalling port and the installation site. It's an economics question, it's a time question, and it's a risk question also. As you increase your marine spread, you will increase your HSE risk, and that's what every developer wants to avoid. We do not want to take unnecessary risk, and we want to limit the amount of time we spend offshore. The faster and more efficiently you finish your offshore campaign, the better you will be. So having a Jones Act vessel is not an ultimate answer. The ultimate answer is how economic can it be, so the end product will be competitive in the market, because this directly ties into your LCOE numbers, which is the levelized cost of energy, which means you have a project, you start developing the project from day one, and you commission on day X, and then you decommission on day Y. You take from day 1 to day Y and divide it by the total cost it costs you, and that's going to generate your LCOE number. So yes, the vessels can be built, but will it be economic and will it be competitive? I think that's the ultimate question we need to look at, and then how the HSE question will play with it. A little bit longer explanation than maybe what is expected, but that's basically how it plays out.
Well, being one of the politicians, what about amending the Jones Act?
It's a lot easier to said than done. So far, we did not. Avia, you talked about the American Wind Energy Association. They are one of the prominent supporters of offshore wind, and then if somebody will do such a thing, it will take a lot of calories, so to speak. And you need a lot of time, and you need a lot of fire and power for that thing. So time is of essence, so you want to manage your time carefully, basically. So you need a non-profit organization to do something like that. Or us developers, we cannot fight that battle.
As a Washington bureaucrat, we often say when things are proposed that, well, gee, that would take an act of Congress. Yeah. Well, in this case, it would take an act of Congress. And it's my understanding of the potential for that kind of a change. Once you open up that act, which is very well entrenched into the American economic system, it's just a monster. It would just become a monster that you're better off finding a workround than you are changing the legislation.
So you pick your battles, basically. Yes.
Well, and I think the workaround is the demand that we have right now. We have demand of close to 20 gigawatts in the Northeast. Hopefully, we'll see steel in the going in the ground in the next year. So we will have an actual project under construction in federal waters. We hope to see close to 3 gigawatts this year awarded in new contracts. So we probably have something on the order of 3 gigawatts of contracts that have been awarded. So projects that have contracts and are going through the development phase, we'll see another 3 gigawatts this year awarded. So we'll have a pipeline of projects from 2020, of construction projects from, say, 2021 to 2026. At that point, the economic decision really changes. And for us to have an industry that isn't 20 gigawatts, but is 200 gigawatts, right. We have to have, we will have local businesses, local manufacturing, local boats being built. I mean, that's how we do it. And it will be driven by the economics. And the economics are being driven by the leases that Jim and his team have been issuing, and kind of the demand pull from the states, and then what folks like Equinor and Shell and the others are doing. I mean, we've taken now some real significant risks up until late 2018. There was some risk, but in the second half of 2018, I think something on the order of $1 billion was spent on leases, whether it was the new leases auctioned off by BOEM or the change of hands from a couple of acquisitions in the industry. We saw over $1 billion of and that's really at-risk money, which kind of gets things going.
Very good. Jim, what do you think has to happen from the federal perspective to make offshore wind work in Texas?
I think from the federal perspective, it can work now. It isn't really the federal perspective that drives it, as we've just finished talking about. It is the economics. And we have what you might call the low-hanging fruit in the Northeast because of the very buildable environment and the wind resource and the tremendous markets. In the Gulf of Mexico, I don't think we're quite there yet. But the structure is in place if The demand were there, and the federal government was approached with proposals to develop wind farms off of Texas, off of Louisiana. We have things in place now where we can move forward. And so I think it's, again, the economics, and we've reached something of a turning point because we've been leasing for 10 years now, and up until about 2 years ago, these leases were going for a song. 2 years ago, 3 years ago, the lease off of New York went went from in the neighborhood of $1 to $2 million previously. The lease off of New York went for $42 million. And this past year, just in December, we had a sale in Massachusetts where areas that were not leased at all, that were put up on the auction block and no one bid on them, were actually purchased, all three of them, for $135 million apiece. So all of that is saying, in combination with the many projects that are going to be built, is that the economics is changing. And when the economics gets to the point, evidently it's going to occur in 2028 for the Gulf of Mexico, the federal government is ready to move forward with it.
Fantastic. Do you think there's a need for technology improvements to bring offshore wind as a viable alternative in Texas?
Well, I'll start with that because when I put in the first wind farm in Texas, my rotor size was 28 feet. And somebody from a newspaper or maybe the Amarillo TV folks asked me what I thought the wind farm standard would be for wind turbines. And I've never really been accused of not thinking big enough, but in this particular case, I said, oh, I think it'll be about 75 to 100 kW, probably not much larger than 125 kW. In 6 years, we were at 500 kW. In 10 years, we were at a megawatt or 1.2. The workhorse standard was 2.2 megawatts. Now we're talking about 6 megawatts that's already flying. We're talking about General Electric with their 12 megawatt turbines, and the rotor that you mentioned has gone from 46 meters, did you say almost 200?
220.
220.
Wow. So we reduced prices in Texas by expanding rotors, getting below 3 cents. I have purchased and as a regulator, I've approved wind projects under 2 cents in Texas and the Panhandle, where we really got a good resource. But absolutely, technology will improve as the industry becomes more mature. And fairly simple things like expanding the rotor and then also just getting a little higher up in the air, because a simple equation, the power in the wind is a function of the cube of the velocity. And so the higher you go up, then the more power you're going to get from that rotor. So what we're seeing here, these are remarkable achievements in wind technology. When I was young, the U.S. government was testing, a 2 megawatt turbine in Washington, 1.2 or 2 megawatt, and I likened it to a flying freight train, and that there would be no way that it works. And of course now that's the standard, and this is what reduces prices, and this is what's going to make it affordable for everybody, so that if there ever is a Green New Deal, it won't cost $94 trillion.
Anybody else?
Like Michael explained, there are a certain amount of VTG providers in the market. GE, Siemens, Vestas, and to some extent Samyang from Germany also. It's a much smaller player, but yeah. So GE and Siemens recently announced Haliade X 12 megawatt and Mark V from Siemens 10 megawatt based on new platforms. So they've paved the road for extension, for capacity expansion. Expansion. So before long, we will see 15 megawatt machines. So as you have the capacity increased, then as long as you sell that power, of course, and you have your project development cost divided by the megawatts you obtain from that particular lease, your LCOE goes down. So the economics improve. That's the basic equation, basically. So yes, it will improve.
And the other part of the equation of the project, the balance of plant, you know, what we've relied on in our construction partners, our fabrication partners, has been developing very large, complex, single platforms. You know, one platform is a tremendous job, and it's a one-off. And here we need now to industrialize the production of the balance of plant, so that, you know, we can have fabrication yards here that are, you know, if I'm building a farm, I may need 100 jackets in a year, and we don't have the sites, the facilities, the practices to really have that industrialized build out. Whether it's jackets or monopiles or floating platforms, but we do need to, you know, really drive the industrialization of those so that the costs, you know, we squeeze out the. Again, it's back to the economics, right?
Yep, that's a great point. Someone's asking about using artificial intelligence and the Internet of Things and how that works into offshore wind now and in the future.
AI, to most extent, will be used in the O&M, operations and maintenance portion. So currently, we are still using humans for checking the turbines on a regular time intervals. The SOVs are used, surface operation vessels. But we are testing in our applications using drones, basically, for continuous 24/7 inspections and with real-time data. GE has an excellent solution called Digital Twin. Mm-hmm. So they have a platform, they have a turbine producing out there in the field. They have a digital twin in AI environment doing exact same thing. So you can actually project the future malfunctions in turbine before it happens. So it is there. It's not actually commercialized fully yet, but very close. The concept is there and exponentially, very speedily developing, definitely.
And that will affect the cost of maintenance.
Exactly.
Yeah.
O&M cost, O&M, again, I'm going back to the same LCOE, but O&M is also part of the LCOE because you are responsible for that facility all the way to the commissioning. So O&M is part of it. If you drop O&M, your LCOE cost will go down.
And we'll see good programming applied in project layouts. That, you know, as we get more operating history from the existing projects, that data will come in. You know, AI is a nice concept, but, you know, what is it? It's really good programming with good data, and we're now as an industry building a database of wind performance and wake effects from existing layouts, and that will all feed into to more efficient site plans. So most definitely in the O&M, and that's where I think, you know, the biggest focus is and should be, but we'll also see it in the upfront design as well.
Mm-hmm. Okay, well, I have one last question for all of you, and then you can give your closing remarks if you'd like to. So who's going to have offshore wind first? Is it going to be California or Texas?
Offshore?
Offshore.
Well, I mean, of those two. It's like that contract I had a problem with. I would say California because they're more progressive, but they're also more environmentally, they've got
There's the avian issues that they might think
They've got
about
all
very
the
carefully.
other issues.
Yes.
That's a really good question. I'll go with Texas.
And you've spent a career investing in Texas, isn't it?
When in Texas?
Yeah.
Why not? Yeah.
What?
Oh, well, then I have to disagree. Just for the sake of argument, if nothing else. I think California, and the reason is when you look at the fundamental factors that make a wind farm go, you have tremendous markets out in California, and you have, to be perfectly frank, better winds out there. You've got a technology issue because the buildable environment is not as good, but they're much farther along in terms of hitting that market spot at which they will move forward with the wind farm. So just to not make it unanimous,
Yeah.
I'll go with
I like it.
California.
Yeah.
Yeah.
Absolutely. It's a supply and demand relation at the end of the day.
Yeah.
You need the market price to support the development. Yeah.
They're thinking about it and talking about it a lot more than we are. So, for sure.
Correct.
Jim, would you like to start with closing remarks?
Sure. I wish I put more thought into closing remarks. I forgot all about them. I'd like to share with you a couple of things. If I was asked 10 years ago, or more like 15 years ago, when the Energy Policy Act of 2005 was passed, that gave us the authority that said, okay, it's time to start thinking about offshore wind, and you can issue leases for offshore wind. And I was asked that question, what can the federal government do? How long is it going to be? I'd say we're years away, and indeed we were years away from being able to move forward with leasing in the offshore environment. It required the development of a regulatory program, a whole auction system, leases and the like, and it took 4 or 5 years. At the time, people were talking about, we'll have steel in the water in just a couple of years, which is to me about the same as saying, yeah, well, we'll have it done by next Tuesday. In fact, it took quite a lot of work to put the regulatory program in place. And I do think that with the regulatory program in place, as the economies come together, as they have in a big way over the last couple of years in the Northeast, you'll see a lot of offshore wind activity in California, and eventually you'll see some wind activity offshore here in the Gulf of Mexico. I think it's an indication of the national system, if you will, to see a need for a diversified energy resource, diversified all of the above energy strategy in the U.S., and that coupled with state desires and coupled with the economy, the economics of the system, you will see movement in that direction. And I'm very, very bullish on what will happen in the offshore wind environment, and I'm very much looking forward to what's going to be happening over the next decade or so.
What would I say? Probably my remark would be, as an engineer, this is almost like a once-in-a-lifetime opportunity. We are witnessing the birth of an industry in this country that didn't exist in the past. Then, as a state in Texas, if I were Texas, what would I do? I would think, what are my strong points? What are my entry points to that particular industry? And in my opinion, the best entry point for Texas would be in the supply chain. We have an established oil and gas background. We have excellent engineers, great companies. We can definitely support this industry, and no other state in the country has that much of a know-how, so to speak. In terms of going back to the same question, California or Texas, which one? You need strong winds. That's an obvious thing, basically. And of course, the market dynamics to support that particular development. Given that condition, I think being able to utilize the strong points that Texas have would be the best entry points for that particular market that's really developing in the very front of our eyes.
Thank you.
So Deniz stole my lines. I think I said I was in a classroom this afternoon, and I told the students that my job is really cool. Working in an area where, we say emerging industry, when there has yet to be a project construction of a project to start in the U.S. waters. Nothing has started yet. It is, we are very much at the front line. I've had, when I started in, kind of active in this a little over a year ago, it surprised the heck out of me how many people said, gee, Shell, offshore wind in the U.S., do you feel like you're late to the party? And I kind of looked around. I thought, well, where's the party? It's a really, really cool, spot, to be in. And so that for people who have the opportunity, I would look at this industry. That you said fun. The second thing, how does Texas get in it? We need your help. We are going to be. We are actively developing projects, and we're going to be actively building projects in the Northeast, for the next decade. And I need U.S.-based companies. I need U.S.-based supply. I need U.S. ingenuity for me to make money developing these projects, and that comes from here. We've got tremendous relationships with Texas-based businesses in our business that has helped us be a incredibly successful company in the energy industry. We've built it in partnership with our supply chain friends. And we need those supply chain friends to think how they can make money supporting the industry, and where the industry is being born is in the Northeast. So I think that's really that's what I would focus. And then back to where is it going to happen? Jim, I think in the next 3 years we'll have rigs with wind on it in the Gulf, whether it's a kite-based system like Makani that we have an investment in, or something else. But we will have oil rigs in the Gulf with wind generation on them.
You heard it here.
When I started in this business, I had this, it was clear to me that there was a pantheon of technologies that would be evolved because it was clear from the very beginning that the cheapest energy we can get is energy efficiency, to add insulation or to change the light bulb. Or to build a passive solar house. So energy efficiency was right at the top of the list. And then, right underneath that was wind power, because we knew that wind power was going to come in at $30 or $40, $50 a megawatt hour, 3 or 4 or 5 cents, and most of you people are paying 10 or 11 or 12 cents, so that's a good wholesale price that can work in the market and not actually increase prices at all. In fact, in Texas, we've lowered prices with our large-scale wind development. And then after wind development, would be large-scale utility solar. That just started about 3 or 4 years ago. I've done a couple of projects already, because it's now around 3 cents or $30 a megawatt hour. And the next big thing that's going to happen is going to be offshore wind, and it's got to happen because the maps that you saw today show that in the Northeast, they're not Texas. And so they're going to have to find a way to get, you know, high-value energy. And I think the offshore approach is going to mature maybe faster than some of us think, especially on the Northeast. And then even here in Texas, you know, as I showed you, we'll be getting up to about 30 gigawatts, 35 gigawatts of wind. We'll have 15 or 20 gigawatts of solar. We still got a 90 gigawatt system to take care of. And so then we'll start going towards distributed solar to where everybody will have an Elon Musk roof on their roof, and by the time we do this pantheon of different resources, then we will end up with basically an electric grid that is powerful enough to run our homes, but also our cars. Because I drove here in my Tesla today, and we need to do a lot of work here in Houston on charging stations. Anyway, it's been great fun to be here, you guys. Nice to chat with you.
Excellent. Thank you very much, gentlemen.
So I want to take the opportunity to thank Cheryl as well as all the speakers here. What a terrific panel. We really enjoyed having all of you here. Just by the number of questions we got a record number of questions this time, over 80 questions. I think this is for a session on offshore wind. These were really, I think the audience is ready to probably come and ask you more questions as we break in a couple of minutes. Before we go to the break, and where we have some hors d'oeuvres and some refreshments, I want to tell you a couple things about what's coming up. On April 18th, we have a symposium on cybersecurity in energy. It's the biggest topic that keeps most people awake. There were questions about cybersecurity, for instance, for offshore wind. I think that's going to come back, and we probably will revisit that issue. And if you've got suggestions for us for next year's symposium series, please do feel free to share that through either the online site or by email to us about topics that you'd like us to cover in the symposium series. With that, I want to thank the speakers and the moderator. I want to thank our sponsors, Equinor and Houston Public Media, and many of the staff from UH Energy and the volunteers from the Energy Coalition for all their effort here to make this a successful program. With that, thank you, and please enjoy the refreshments.
Thank you, sir. It's a pleasure. Nice to meet you.